Hello everyone and welcome back to my channel. Today we are going to introduce ourselves to an incredibly useful topic in linear algebra, eigenvalues and eigenvectors. If you are an undergraduate student studying mathematics, engineering or even computer science, you are going to encounter these concepts a lot. Imagine you have a matrix, let's call it as A. Matrices, as we know, can represent linear transformations. They can stretch, rotate, or shear vectors in a space. Now what if I told you that there are special vectors that when multiplied by A only get scaled? They don't change directions, just their lengths. These special vectors are called as eigenvectors and the scaling factor is called the eigenvalue. Consider the equation A into V is equal to lambda into V. This equation is the heart of eigenvalues and eigenvectors. A is our matrix, V is the eigenvector and lambda is the eigenvalue. Notice how A times V results in just a scaled version of V. The direction remains the same. Let's think about this geometrically. Imagine V is an arrow. When we multiply it by A, it might get longer or shorter or even go in the opposite direction. The eigenvalue lambda tells us how much the vector is scaled. If lambda is positive but lesser than 1, then the vector shrinks. If lambda is greater than 1, then the vector gets elongated. And if the value of lambda is lesser than 0, then the vector stretches in the opposite direction. You might be wondering, how do we actually find these eigenvalues and eigenvectors? For that, we need to find out the characteristic polynomial, the characteristic equation, and the characteristic roots. We'll delve into the mathematical processes in the next video. We'll explore the characteristic equations and how to solve for eigenvalues and then find the corresponding eigenvectors. So make sure you subscribe and hit the notification bell so you don't miss that one. Understanding how to calculate eigenvalues and eigenvectors is crucial. Thanks for watching. Let me know in the comments if you have any question. And as always, happy learning.